Hey guys, welcome to today's lesson. We are looking at the parabola and the domain and range, mainly for the 2-unit mathematics course in year 11. Okay, to start off with, guys, I've drawn out the function of x squared plus 3x minus 4. You should be able to sketch that and all the necessary features, but we're going to double check that just to make sure. So first of all, what are the features that we look for? Well, like any graphs, we always want to look at the y-intercept and label that, the x-intercept, label that, and then for the parabola, our axis of symmetry and also our turning points are all very, very important features. And they're going to allow us to find the domain and the range because we can see it. So I'm going to start just by graphing my x and y axes. And then I'm going to look at the y-intercept. Now hopefully remember the y-intercept is simply that -4. Now why is that? Well, that's because if I substitute 0 in for the x value, we get 0 plus 0 minus 4. Therefore, f of x, or y, equals -4. Okay? Remembering too, that could be y equals x squared plus 3x minus 4. The f of x is just another way of writing that. It's called the function of x. Okay, so I'm going to put down here -4. That is where my y-intercept is going to be. Now, how do we find the x-intercept? Well, similarly to find the y-intercept, I'm going to throw in this time not y, so not x equals 0, but I'm actually going to put that y equals 0. In other words, 0 equals x squared plus 3x minus 4. Now, why do I put y equals 0? Well, think about it. Y equals 0 is right here along this x-axis. Therefore, if I chuck in y equals 0, we can then find where the x-intercepts are going to be. So let's have a look now. Let's solve this by factorizing, because it is a quadratic equation that you've kind of formed. That's going to be x plus 4 and then x minus 1. And then if I solve that, we get x is equal to -4, x equals to +1. If you're not sure how to solve quadratic equations, guys, you need to go back and look at that lesson. Okay, so I've now clearly found my x-intercepts. We've got -4, which will be around here somewhere, and we've got +1. Beautiful. Okay, this is just a sketch, so it doesn't have to be perfect. Now, what I want to find, because what I've got at the moment is I've kind of got my parabola kind of doing this thing. And the thing is, I don't really know how far down to draw it. So what's going to help us is knowing what the axis of symmetry is going to be, because then I know what the x-coordinate is of this particular turning point, and then we can actually put it back into the equation to find the y value. So how do I know what the x-axis or the x value at this point is going to be? Well, if you're not sure, you could kind of like look at it and go, it's halfway between -4 and +1 and work backwards. But we do have a formula for that, which is x equals -b over 2a, which is very easy to use. Remembering though that all parabolas are in the form of ax squared plus bx plus c. So in this case, we've got -b, which is -3, all over 2 times a, which is 2 times 1. So we get -3 over 2, or -1.5. So I guess if we put -1, -2, -3, -4, you can see that that's the graph of x equals -1.5. Alright, now why do we need that again? Well, we want to find the turning point down here, or the minimum point. We know the x-coordinate now, so all I need to do is to sub it back in to find out what the y-coordinate is going to be. So I'm going to chuck in the -1.5 there and get -1.5 squared plus 3 times -1.5 minus 4. And I'm going to put that into the calculator to get my answer. And that will be -6.25. So that's going to be -6. So I'm going to put the coordinate there actually as -1.5, comma, -6.25, or you can do -1.5 and -6 1/4. Okay, so we've now sketched a really nice parabola, and often what these questions will ask us are to find the domain and the range. Well, our domain means we're looking for all the x values, and are there x values for this whole parabola? If I look at negative values, Yes, they're going to be all on this graph. If I look at my positive values, yes, all the x values are still on this graph. They all exist, which means that we have all real x values. Okay, if I look for my range, which we know our range are talking about our y values, if I look at the positive y values, yep, actually we've got 2 at that point. If I go across there, yep, got 2 there. If I look at 0, yep, we've still got 2. If I go down to here, we've got 2. If I go down past -6 1/4, what happens? If I go -7, there are no points on my graph, which means that my y values are greater than or equal to -6.25. Okay, so that minimum point that we found there for y. So again, that's quite challenging. There's a lot involved here, but it comes down from sketching a nice parabola. So what we're going to do now is going to look at a couple of different questions, just 2 questions. So first of all, you might want to pause this, try and sketch it, and then find the domain and range for you. Now this is the same question, so I'm just going to change this slightly. Okay, so we're going to find the function x squared plus 5x. I want you to sketch it, and then I want you to find the domain and range. Okay, so how'd you go? Let's see what we want to have. We've got the y-intercept. Now in this case, the y-intercept, there's no plus 0, is there? If I put the x is 0, 0 plus 0, we have a y-intercept of actually 0. There's not one there, but it does go through 0. My x-intercepts are where I want to solve my equation. So I'm going to chuck in y equals 0 and get 0 equals x squared plus 5x, create my quadratic equation. I'm now going to factorize it to solve it, and then I've got x is equal to 0 and x equals to -5. If I want to have my axis of symmetry, we can have x equals -b, which is -5, over 2a, which is -2.5. And then if I want to find out my turning point, we're going to chuck it back into -2.5 all squared plus 5 times -2.5, and that will equal, funny enough, -6.25. Alrighty, now this time what I've done, I've gone through and I've found all my features first. So now what I'm going to do is I'm going to sketch it. Again, it's just a sketch, it doesn't have to be perfect. So I've got there my y-intercept at 0. We've got my x-intercepts at 0, -5. We've got the y, so axis of symmetry at -2.5. So 1, 2, 3, 4, and 5. So -2.5 will be sort of straight down the middle. And we've got -6.25. So 1, 2, 3, 4, 5, 6, and be about there. Okay, so I'm going to sketch it now. So it comes through nicely. Again, it's a bit hard for me to draw in here. Hopefully yours looks a bit nicer. And we've got our nice parabola as such. We've got my x-intercepts, which also includes my y-intercept. We've got my turning point. So if I want to find the domain of course is all my x values, and for all parabolas, they all exist. So we've got all real x. For my range, which is my y values, they don't all exist because the minute I go under -6.25, they don't appear. So we don't have y is greater than or equal to -6.25. Alrighty, one last question, because realistically the only difference is going to be is how you sketch your graph, and often it's going to be on how you solve to find the x-intercepts. But this is a question I wanted to do because it's a negative graph, which means that our parabola is going to be something like this. It's going to be unhappy in some respects. We'll hope not that one. It might have some x-intercepts there. So what do? Well, we go through the same process. We want to find our y-intercepts, our x-intercepts. We want to find our axis of symmetry. We want to find our turning point. Straight away, I can see that my y-intercept is 6, so that's nice and easy. My x-intercept is going to be a little bit more challenging. So if I go down here, do my factorizing, 0 equals -x squared minus 5x plus 6, which means when I'm solving this equation, unless of course you're using the quadratic formula, which you're most welcome to do, you've got a negative x squared, which makes it a bit more challenging. So what I'm going to do is factorize the negative out first to make x squared plus 5x minus 6, and then I'm going to solve it like I would normally do for a monotonic quadratic. So I'm going to have there, we'll do x plus 6 and x minus 1. Okay, that makes 5 and it makes negative 6. That works out. Therefore, x is equal to negative 6 and x equals 1. Be careful. This negative here has no bearing on what's inside these brackets. Okay, so they're still my x-intercepts. So x is equal to negative 6 or x equals to 1. So they're my x-intercepts. Now my axis of symmetry, I don't need that anymore. That's all gone. My axis of symmetry is x equals negative b. Well, b in this case is negative 5. So negative b over 2 times negative 1, which makes it 5 over negative 2, which equals negative 2.5. Okay, and then if I put that back in to find my turning point, we're going to get negative brackets negative 2.5 squared minus 5 brackets negative 2.5 and plus 6. Be really careful, guys. I do see a lot of problems occur here when people don't use brackets to substitute, because obviously when you square a negative number, it's going to become positive, but notice also there's a negative still outside the x. So it does get quite confusing, so you need to be really careful when doing these particular calculations. Okay, I'm doing this one and I get 12.25 as my turning point. The good thing is, if you do make a mistake, what's going to happen most likely is when you sketch it, they're not going to add up properly. They're not going to look correct. Okay, so we've got a y-intercept of 6, and it goes up to 12.25. So I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14. Okay, again, you don't have to be exact, because all it's asking me about is the domain and range, really. But I'm going to put those there. So we're going to put on my y-intercept of 6. Now we've got axes, so x-intercepts of negative 6 and 1. 1, 2, 3, 4, 5, 6. And positive 1. So I'm going to plot those on there as well. We've also got an axis of symmetry at negative 2.5, so negative 1, negative 2. So it's going to be straight down the middle of those two. And then we've got my turning point, of course, at 12.25, which is just up here. And you can see how it does work out quite nicely. Of course, if you've got your turning point down the bottom there, you know something went sort of incorrect. So I'm going to draw my parabola from there. Again, hopefully yours is a bit smoother than mine. And look at that, a really nice negative parabola. Now for my domain and range, well, like all parabolas we've seen so far, we have all real x for my domain. For my range, however, y must be less than or equal to 12.25. Okay, now I know this has been a long tutorial, guys. I do apologize, but I hope that made a bit of sense. I'm both revising how to sketch parabolas, but of course, then how to read your domain and your range from those parabolas. Have an awesome day, guys. If you need any help, please let me know. This particular set, we'll be looking at exercise 5.8 from the Blue Maths in Focus textbook. Have an awesome day, guys.